Today's lesson is going to be on shortest paths, okay? So it's nothing tricky. The shortest path between two vertices is the path where the sum of the weights of its edges is minimised. It's just, if you're adding up the numbers, up the weighted edges, it's the shortest or the smallest number you get, okay? It's not a minimum spanning tree. For some reason, people get that confused. So it's just the smallest or the lowest adding of the weights. Alright, here's an example straight out of the textbook. Find the shortest path between town C and town F. Okay, so I'm just going to highlight over it where I think the shortest path is. So it looks like there's 5 plus 4 plus 7, so that's 16. Okay, now I can check. I could go 5 plus 5 is 10 plus 9 plus way bigger than 16. I could go 5 plus 7, 12 plus 6 is 18. So that's the shortest path. Okay, so how do I write that? So I tell you what the shortest path is. It's C to B to E to F. And I should have added, did I add this up? I should have added that up and said the shortest path is 12 kilometres, which I thought, oh, I did. Sorry, 16 kilometres. Okay. Example 15 from your textbook. Find the length of the shortest path between, we'll start off A and E. So the shortest path A to E, there's A, there's E. Just a quick look, I can go 6, 5, I can go 5, 7. So 6, 5 is shorter. So 6 plus 5 is obviously 11 units. And the path is, we say A to C to E. Part B, shortest path A to F. Alright, and you can look and play, but I think it's just basically 6 plus 6. Okay, so it's 12 units, and the path is A to C to F. Part C, A to G. A to G. Again, just glance around. 5 and 7 is 12. 12 plus 10 is 22. I think it's quicker this way. 6 and 6 is 12 plus 8 is 20. Okay, so 6 is 12 plus 8 is 20. Could have also checked this way. 6 and 5 is 11 plus 10 is 21. So that is the shortest route. I have to state it. 6 plus 8 is 20, and the path would have been A to C to F to G. Okay, and A to H, all the way here, or to all the way over there. Just looking at it quickly, 6 and 8, we know what was that, 12, 20, that's 30 that way. 5 and 14 is 19, that's 31 that way. 6 and 5 is 11, 10, 31 that way. So the shortest path is going to be that way. It's 30 units long, and it's A to C to F to G to H. So we're looking at the shortest path. We are not creating a minimum spanning tree. Last example out of the textbook. Darcy has drawn a network diagram to represent several streets for travelling from his home to the shops. The numbers indicate time in minutes. Describe the shortest path and the minimum travelling time. Alright, so let's go this way first. 1 plus 2 plus 5 plus 3 was 8, 9, 10, that's 11 that way. I think this way is shorter. 2, 3, 2, 3. It's 5 and 5. So if we actually go that way, 2 and 3 is 5, 2 and 3 is 5, so that's 10. That's the shortest path. I would check this way. 4, 5, 6, 11 again. Okay, so you keep checking all the different ways, but that was, to me, the quickest. Describe the path. A to B to C to F to I, and it took 10 minutes. And I'll put my units in. When they give me units in the question, I'm going to put units in my answer. Okay, shortest path. So it's the last exercise on networks. There's plenty of work to do. Enjoy.